Welcome to day 2 of section 5-6, where we're still talking about parallel and perpendicular lines. Today our focus will be on perpendicular lines. Let's do a quick warm-up here and review what we did in the first part of this section, where we are writing the equation of a line that passes through the point and is parallel to the graph of the given equation. So our point is 3, 2. Our equation is y equals 3x minus 2. Go ahead and come up with the equation and we'll see how you do. So we know that our slope is 3 because, again, we were given the equation in slope-intercept form, so we can easily pick out our slope. Since we have a slope and a point, we're going to use point-slope form. Y minus y1 equals m times x minus x1. Here's our x1 and our y1, and we picked out our slope, so we fill in the values. Y minus 2 equals 3, and then in parentheses x minus 3. We need to distribute. So we have y minus 2 equals 3x minus 9. They said to put this in slope-intercept form, so we add 2 to both sides to get y equals 3x minus 7. Our vocabulary word for today is perpendicular lines, and perpendicular lines are lines that intersect to form right angles. You may remember from your previous geometry lessons that a right angle is this, when they intersect and form that 90-degree angle. Take a look at these pictures and see if you can find any perpendicular lines. Again, I've highlighted some of them. The track is perpendicular to the little slats. The lines here are perpendicular. The dotted lines on these are perpendicular, and then all of these lines that form these corners are perpendicular. Again, there may be more that you find, and that's fine. Take a look at the lines that I have graphed here. See if you can come up with some similarities and differences. Here's what I came up with for similarities. They're all straight lines and they're all linear. The difference is some of them are increasing and some of them are decreasing, so they seem to have different slopes. Before we move on with perpendicular lines, we need to review reciprocal. And a reciprocal is if you have a non-zero rational number, in other words a fraction, a over b, the reciprocal, or it's also known as multiplicative inverse, is b over a. When you multiply the product of a non-zero number and its reciprocal, you're going to get 1. So for example, 2/5 and 5/2 are reciprocals because, first of all, they're flipped. The bottom number went to the top and the top number went to the bottom, but also when you multiply them together you get 1. You get 10 over 10, which simplifies to 1. We're going to need to work with reciprocals today, so let's do a little more practicing here. The product of a number and its reciprocal is what? And circle the numbers that are reciprocals. So go ahead and take a second and do those, and we'll see how you do. The product of a number and its reciprocal is always 1. These numbers are reciprocals because I can write 7 over 1 and make that a fraction and then flip it to get 1/7. 1 and -1 are not reciprocals. 0 and 0 over 12 are not reciprocals. -3/4 and -4/3 are reciprocals. The tops and bottoms have been flipped. Now, when we're coming up with equations for perpendicular lines, they're going to be perpendicular if the product of their slopes is -1. So in order to get that slope or that product to be -1, we're going to have opposite reciprocals. So if you happen to have a vertical line and a horizontal line, those would be perpendicular. So if you're given a vertical line, you're going to want to come up with a horizontal line to be perpendicular to it. And if you're given a horizontal line, you'll want to come up with a vertical line that's perpendicular. So let's take a look at our question here. It says the slope of a line is 2. What would be the slope of a line perpendicular to that line? Well, I need it to be opposite of 2. So the opposite of a positive 2 is going to be negative, and I need it to be the reciprocal. So the reciprocal of 2 is 1 over 2, because again, 2 can be written as 2 over 1, and then I flip that upside down. So my answer is D. Let's take a look at an example. Because in your homework assignment, what you'll be doing is you'll be coming up with equations for perpendicular lines when they give you a point and a line that they want it to be perpendicular to. So in our example, we have a line that we want to pass through the point 1, 8, and we want it to be perpendicular to the graph of y equals 2x plus 1. So first thing we need to find is our slope. Again, we're given our equation in slope-intercept form, so it's easy to pick out our slope, which is 2. We want the opposite reciprocal of that, so we make it negative because our original slope was positive, and the reciprocal of 2 is 1/2. You can always double check to make sure you're correct by taking the original slope times what you think is the opposite reciprocal and making sure you get that -1. So our slope of our line is actually going to be -1/2. Again, we have a point, we have a slope, so we use point-slope form. Y minus y1 equals m times x minus x1. We have x1 and y1 and our m, so y minus 8 equals -1/2 times the x minus 1. Distribute the -1/2, so we have -1/2 plus 1/2. Add 8 to both sides, so we end up with an equation y equals -1/2 x plus 8.5. And you can have those halves as decimals if you'd like, that's fine. Let's take a look at another example. We have our point 3 and -6 and our equation x plus y equals -4. First thing we need to find is our slope. You'll notice they've given us our equation in standard form, so it's not easy to pick out the slope. We actually have to move this stuff around so that we can easily pick out our slope. So what I'm doing is I'm putting this into slope-intercept form so I can easily pick out my slope. So I'm subtracting x from both sides so that I now have y equals -x minus 4, so I can see that my slope is -1. Now I have my slope. They gave me my point. Again, using point-slope form, I use y minus a -6 equals -1 x minus 3. Distribute that -1. I get y plus 6 equals -x plus 3. They want our equation in slope-intercept form, so we're going to subtract 6 from both sides to get y equals -x minus 3. Another example, we have a -9 and a 3 for our point, and our equation 3x plus y equals 5. Again, you'll notice that they do not have this in slope-intercept form or point-slope form, so we have to move it to slope-intercept form to easily pick out our slope. So we subtract 3x from both sides. We end up with y equals -3x plus 5, so we see that our slope is -3. They gave us our point, so we use our point-slope form. Y minus y1 is 3, so y minus 3 equals -3 times x minus a -9. We fix this double negative, so we have y minus 3 equals -3 times the quantity x plus 9, and then we distribute the -3. So y minus 3 equals -3x minus 27. Add 3 to both sides to get y equals -3x minus 24. A final example here, we have our point. This time they've given us our equation in point-slope form, so it's easy to pick out our slope of -2, so we don't have to do that work for this particular problem. We have our slope, we have our point, we use point-slope form. Y minus 3 equals -2 times the quantity x minus a -8. We need to fix that double negative, minus a negative is a plus, and then distribute our -2. So y minus 3 equals -2x minus 16. Add 3 to both sides, so we get y equals -2x minus 13. Homework assignment for this section is on page 331, numbers 19 to 24.